This is a two-part question. The first part asks us, when is a rational function discontinuous? Well, let's recall what a rational function is. A rational function is simply one polynomial divided by another polynomial. Now, a polynomial is continuous everywhere. The question is, what happens when we decide to divide one by another? Well, let's start by thinking about what typical graphs of rational functions look like. Right? Sometimes, not always, but sometimes they might have a vertical asymptote, right, like that guy, or sometimes they might have a hole, right, or some combination of either of those features, sometimes none of them. But notice that outside of the hole and the vertical asymptote, the function is continuous everywhere else. So really, where a rational function is discontinuous, you're going to get either a hole or a vertical asymptote. And those things will happen when the bottom polynomial is equal to 0. Right? When the bottom's 0, our graph might have a hole in it, or it might have a vertical asymptote. So to answer the question, where is a rational function discontinuous? It is discontinuous at the x values that make the bottom polynomial equal to 0. And part B of this question asks us to apply this to a particular function to determine where that function is discontinuous. So where is the function f of x equal to x squared minus 1 over x squared plus 3x plus 2 discontinuous? Well, again, this is a rational function. It's one polynomial over another polynomial. It'll be discontinuous where the bottom is equal to 0. So let's go ahead and find where the denominator is 0. So setting the bottom equal to 0, we notice we have a quadratic equation here that happens to be factorable. It factors as x plus 1 times x plus 2. So the bottom is going to be equal to 0 when x is negative 1 and when x is equal to negative 2. So this rational function is discontinuous at these two x values.